Hi everyone, today we are going to talk about the unit circle. So first, I need you to go to the Desmos activity in Canvas and work through it. And you'll follow along on this paper with your activity. So anytime you have a bracket with a number inside it in the bottom right corner, that's what slide it goes with. So you'll fill out the notes as you go through the Desmos. Pause the video to do that, and then you'll come back to finish the notes with the video. All right, all of the answers to those pages are in the Desmos, so you have to do the Desmos to get those things filled in. Now for the rest of this, we're just going to go through some important things to kind of debrief. Hopefully you saw how radians work in the Desmos activity. We do have some formulas we can use, and so to convert from degrees to radians, we multiply by pi over 180, and to convert from radians to degrees, we multiply by 180 over pi. So we'll do a couple of examples. I like to write these as fractions vertically so I can see how they come together here. And so we'll cross out the pi's. And we'll reduce the 18 and the 3 to be a 6 or 60. And then 4 times 60 is 240. Go straight across. Do the same thing on the next one. And so we will cross these off. And then this one is a little bit harder, but 180 over 4 is 45. So you can use a calculator if you like, and then 7 times 45 is 315 degrees. Next, we will multiply by 180 over pi. So I just like to write it like that, and then I reduce it. 45 over 180, we just said that's 4, goes into it 4 times. And we'll do this one too. We can reduce 12 into 18 is 2/3, and the zeros will cancel, so it's just 2 pi over 3. So anything with a degree symbol is a degrees, and then without it, you can assume it's pi over 4 radians, 2 pi over 3 radians. Usually when there's a pi, it's a radian. All right, we need those for our unit circle because we work with both radians and degrees, mostly radians. And so we'll first go back to degrees. These are our main 3 triangles that we use to make the unit circle, so I'm just going to briefly go into how that gets made. For a 30, 60, 90 triangle, that's what this one is right here. We'll just highlight it. What we want to find is the coordinates that go with this. So this is the unit circle. It's got a center at 0, 0. So we want to know what is this x coordinate and what is this y coordinate, so we can find the values like you did in your Desmos activity. And so a sine of 30, or either one, and we'll just fill in the triangle. Basically, the side across from a 30 degrees angle in the 30, 60, 90 is half the hypotenuse. So if the hypotenuse is 1, then that side is half of it. And then across from the 60-degree angle is the short side times the square root of 3. So that's going to be square root of 3 over 2. So what that means is the x is square root 3 over 2, and the y is 1/2. And so now we know sine of 30 is 1/2 and cosine is square root 3 over 2. With a 45, 45, 90, the rule is that the 45-degree sides are the same length, and the hypotenuse equals the side length times the square root of 2. And so this is 1 over the square root of 2. But we don't like the square root in the bottom, so we do what we call rationalizing it, and that's multiplying by the bottom square root so that it will get rid of it. And that's square root 2 over 2. And that would be the case for both the x and the y coordinate because it's a nice isosceles triangle. 45, 45 degrees are the same angles. That's square root 2 over 2, square root 2 over 2. And then this other one, this is just the same triangle as the first one, it's just flipped, which means that what was the x before is now the y, and what was the y is now the x. So the way I remember these is that I just think of this as the long x. So I think of square root 3 over 2 as long, and then I think of 1/2 as short. That's how I remember them. And then we have our other angles. This one is 0 or 1, 0, 0, 1, negative 1, 0, and 0, negative 1, because it's got a hypotenuse of 1, radius of 1. So we're going to show you the filled in circle here. It's already filled in on your notes as well. So I just want to highlight a few things. Basically, all of the 30-degree triangles are also over 6. The ones that are close to the x-axis. And so I like to think of these as having long x, short y. Then we have our isosceles triangles here, which are over 4. And they're in the middle of each quadrant. And they have same x and y. And then we have our over 3s here, which have the opposite of the first one, so a short x and a long y. And then we have our, I like to call these like the key points or something like that, or the 4 corners, sometimes I call them that, because they are the whole numbers on all 4 sides. And then if you notice, we just have a couple of things about the signs. We have positive, positive in the first quadrant, negative, positive in the second, negative, negative, and positive, negative. That's just using conventions of a regular coordinate plane. And then a couple other things I want to make sure that you guys know is that we have x is the cosine of the angle, y is the sine of the angle, and then we have 1 over x, that's going to be the secant. 1 over y is the cosecant. We have x over y is cotangent, and then y over x is tangent. So you'll need to know all of those as well to be able to answer the questions on the next slide. All right, so I'm just going to do these pretty quickly so that we can get through them. What I like to do is I like to draw a little circle, and I like to imagine where pi over 6 is. I don't want to do the whole circle, just that, and then I write the coordinate for that one, which has a long x and a short y. And I just fill in the whole thing. Sine is y, cosine is x, tan is y over x. And so we'll fix that up and multiply by the reciprocal. We like to rationalize when we need to, when there's a square root in the bottom. And so the tan is actually square root 3 over 3. Cosecant is sine flipped, so 1 over y. And so I'm just going to flip 1/2 and do 2. Secant is cosine flipped, or 1 over x. So I'm going to flip square root 3 over 2 and have 2 over square root 3. And then we need to rationalize. And cotan is x over y. And so that's going to be square root 3 over 2 over 1/2. And so we need to multiply by the reciprocal. And this is cotan. So I want you guys to try the second one, and I'm going to do that one really fast. So you can try it yourself first and then check the answers with me. And I'm going to go through them very quickly. 5 pi over 4 is down here. So that ordered pair is square root 2 over 2, square root 2 over 2, and then it's negative. And then we will do the sine, which is the y, the cosine, the tan. When you divide something by itself, it get 1. Cosecant will flip and rationalize. And then we really just get negative square root 2. So that you can always just remember that. For cosecant, same thing with secant, it will be the same answer because the x and the y coordinates are the same. And cotan will be the same because the x over y is the same thing over itself, 1. We'll do 2 more, try to be quick. You can try these on your own, but before we do, let's make sure you know This is way too big, so we need to subtract 2 pi from it. So that's really 2 pi. Remember, we're finding the coterminal angle, and so we're really going to be looking at 5 pi over 3, because they'll have the same coordinates. So if I draw that, that's this one down here, vertically long, and it has a short x and a long y, but a negative y. Tan y over x, and so that's going to be negative square root 3 cosecant. Flip the sign, rationalize it, secant, flip the cosine, and cotan is going to be the opposite of tan, and so that will be rationalized to negative square root 3 over 3. If I do anything too fast, just pause and work it out yourself, and then unpause to make sure you got the same answers. Last one we'll have is pi. Pi is right over here, so that coordinate is negative 1, 0. And so when we do this one, sine y, cosine x, tan y over x, and so that's 0 still. Cosecant is 1 over sine, and so you can't divide by 0, that's going to be undefined, is the answer. Secant is 1 over x, so that's negative 1 still. And then cotan is x over y, and so that is undefined as well. All right, a couple more things. There's a little tricks in here. So sine of negative pi over 3. So you have a couple ways to do this. One, if this is positive pi over 3, then this one is negative pi over 3. And so our ordered pair here is 1/2 negative square root 3 over 2. Sine is negative square root 3 over 2. Another thing you could do is find the coterminal angle and find the sine of 5 pi over 3 instead, which is the same angle that we did use. So either one works. Next one, tan is too big, so we need to subtract 2 pi, which is just going to be 12 pi over 6. And so I get 5 pi over 6, which is this angle, close to the x-axis in the second quadrant. And so that has a long x, short y, and negative x. Tan y over x. And so we get the rationalized denominator version of tan there. Okay, last couple things is just taking values as answers and finding the angle that goes with that value. So where on the unit circle, this is saying, for what angle does sine equal 1/2, or y is the main thing. And so if I look at my unit circle, a y of 1/2 happens close to the x-axis, positive. And so those values are pi over 6 and 5 pi over 6. I don't like to see secant because I think that's tricky looking. So I'm going to change this to cosine. And where is the cosine equal to 1/2? Because we'll flip this. And so that is here and here. Short x, but on the positive side. And that's at pi over 3 and 5 pi over 3. Now this tan is a little tricky, so what we want to do is just think about how we got here. If you look, it is rationalized, and so that means that the square root 3 was on the top, and the 1/2 was on the bottom to get us that. And so I know my ordered pair is 1/2 times this 1/2 square root 3 over 2, or negative 1/2 negative square root 3 over 2. Because remember, with tan, if positive, positive, or negative, negative will have a positive tan. And so that's going to be this one or this one, which is pi over 3 or 4 pi over 3. Last one here, we have a rationalized thing, and so we know originally this was sine, and we know it was negative square root 3 over 2 because of the way this was rationalized. And so that means it was flipped and became that. So when sine is really large and negative, it's this one and that one, which is 4 pi over 3 and 5 pi over 3. I love doing these. I feel like they're like little puzzles. So the main thing is that you really know this unit circle right here and everything on this page. So if you start to try to memorize it, that's great, or also just like memorize a couple of things in your head so that you can do it as quickly as I just did it. All right, thank you so much. Have a great day. Go to Canvas to check what's next.